Okay, we are online. Good morning and or good evening, everyone, and thank you for joining us for our final session of our webinar series. My name is Simone Serafini, marketing specialist at VIS Hydraulics and SmartFluidPower, and I'm pleased to welcome you to today's live session. First of all, I'd like to thank those of you who have been following the series from the beginning, as well as those who took the time to watch the recordings. Your engagement clearly shows how relevant is the topic of simulation is becoming in today's fluid power industry. As systems grows, more complex and performance requirements continue to increase. Simulation is no longer just an optional tool, it is increasingly becoming an important enabler for more informed and efficient engineering decisions. Throughout this webinar series, our goal has been to provide practical insights, real use cases, and concrete tools to help you better understand how modeling and simulation can support your design process and innovation efforts. If you missed any of our previous sessions, you'll find the link in the chat to catch up. And with that said, let's move on to today's topic, how to introduce simulation into company processes. Where should you start? What are the common challenges? And how you can approach this in a structured and effective way. To guide us through this topic, I'm pleased to introduce Giovanni Cillo, co-founder of SmartFluidPower. And Giovanni, the floor is yours, and to all of you, enjoy the sessions.
Good evening, and I am Giovanni Cillo, and I'm one of the founders and directors of SmartFluidPower. For those who don't know us, SmartFluidPower focuses on lumped parameter dynamic simulation with a specific emphasis on fluid power. SmartFluidPower is an innovative SME. It was founded in 2018 as a spin-off of the University of Modena and Reggio Emilia. And this company currently consists of these 7 partners, all coming from the fluid power field with backgrounds in academia, in research, and also in industry. As you can see, our customers all belong to the fluid power sector. We mainly operate in hydraulics, but more generally also in pressurized fluid systems, including fuel, water, and similar applications. We focus on virtual simulation. So what is a virtual model? A virtual model reproduces the behavior of a system or a component and helps reduce the number of physical prototypes and experimental tests. In addition to reducing the physical prototypes, it allows also testing many designs, configurations directly on the computer without building anything physically. This is useful both in the prototyping phase and also in redesigning activities. It also enables fast optimization of an already developed design, reducing time and costs and improving time to market. Our main strengths are based on the use of Modelica language within an open source environment that is created for multi-domain systems. This environment promotes co-simulation through model exchange using the FMI standard. We adopt a block-based modeling approach, which is fast, intuitive, and it is based on lumped parameters. SmartFluidPower provides custom services dedicated to the software integration into company processes, and as I said, our team is completely specialized in fluid power. So our main tools are OpenModelica, that is an open source environment for dynamic simulation of multi-domain systems and promotes co-simulation through the FMI standard. Our libraries that are written in Modelica code and are specialized for the fluid power sector with a lumped parameter approach. For those who are familiar with simulation, this differs from distributed parameter approaches such as CFD or FEM that can be steady state or fatigue based. Our approach is on the other side, is based on lumped parameters, meaning that special effects are approximated, while system dynamics are fully captured over time. So this simulation is 0D or possible one-dimensional. We have developed several libraries: a hydraulic library, including simplified models of valves, pipes, orifices, and so on; a mechanical library, divided in translational and rotational components; a component library used for detailing modeling of elements such as poppets, spools, leakages; a signal library containing blocks used to provide inputs to and control the system; and a fluid package used to define the properties of the flow that is, in our case, nearly incompressible. In addition, we also provide the development of custom libraries, models, and also user interfaces, other consulting activities, including CFD analysis for models calibration, and also training and support. So we work on two fronts. On one side, we develop software tools, and on the other, we support companies through consulting activities. But the core of our work is not simply doing simulation. It's about bringing the simulation into company processes. Before moving forward, it's useful to briefly recap the path that we have built through the previous webinars, because today's session is the natural conclusion of the entire series. So in the first webinar, we introduced the fundamental concepts of dynamic simulation, focusing on why it has become increasingly important to predict system behavior before physical implementation. In the second webinar, we went deeper into modeling, showing how to represent fluid power system through dynamic models and the advantages that this approach brings in understanding the general system behavior. In the third webinar, we shifted toward real industrial applications, discussing how simulation can be integrated into product development, and presenting an example from a real company, such as the VIS Hydraulics Innovation Center. In the fourth webinar, we focused on performance and energy optimization, demonstrating how simulation data can be used to make concrete design decisions. At this point, one key question remains. Even assuming that simulation is useful, is accurate, is capable of supporting product development and optimization, how can it actually be introduced into company processes? How do you move from an occasional or an experimental use to a daily operational tool? And this is exactly the focus of today's session. In this webinar, we will explore the typical barriers to simulation adoption and, most important, the tools and the approaches that can help companies to integrate simulation into their workflows. If we look at the typical process followed by many companies that use simulation, we can recognize a common sequence, starting from 3D CAD, building a mathematical model of the system, moving on to dynamic simulation or to simulation in general, and finally reaching the behavior of the real machine. This approach really already represents a step forward compared to a development process based purely on physical prototypes, as it allows to anticipate, as I said, part of the design validation. However, in practice, simulation often remains confined to a specific phase of the process, and it is not truly integrated into the decision-making workflow. In many cases, it only comes into play when issues arise during testing, or even directly in real-world applications at the customer's application. The key point, therefore, is not simply to use simulation, but to understand how to make it a continuous part of the product development process. This is where the central theme of today's webinar is focused. How to transform real simulation from a tool used occasionally into a continuous support for technical decision-making. This representation follows the so-called VU model, a widely used approach in development of complex systems, as it connects design phases with verification and validation activities. On the left-hand side, system requirements and architecture are defined. In the central part, development takes place, while on the right-hand side, components, subsystems, and the final product behavior are progressively verified. The colors represent the different level of abstraction of the activities. However, the key point is not the sequence of phases, but the fact that simulation must now be integrated in the entire development process. Already in the early stages, it helps them identify constraints and critical issues even before detailed designs begin. During development, it allows designers to compare alternative solutions, reducing the need for physical prototypes. In the integration and validation phases, it supports, for example, system behavior verification and comparison with experimental results. Finally, it also helps progressively align the model, the virtual model, with the real product, improving subsequent design iterations. The most important aspect is that this process is not one-directional. The most important thing is that data collected from the real product flows back into the model, enabling a continuous improvement of both simulation and design. In this way, the simulation becomes a continuous element of the development process, reducing the gap between the virtual model and the real-world operation. The key point is, today, very few people question whether simulation is useful. Its benefits are clear in terms of costs, time, and repeatability. So why doesn't it become an everyday tool in many companies? The barriers are always the same. The first is skills. Dedicated roles are often missing. The second is time. Building a model requires an initial investment in both resources and personnel. The third is integration. Simulation is not fully embedded in the decision-making workflow. And finally is trust. If the model is not well understood, it tends to be perceived as unreliable. Taken together, this factor explains why there is still a gap between the potential of simulation and its actual use in companies. For these reasons, SmartFluidPower should not be seen simply as a software provider. The goal is to build a complete pathway that supports companies in adopting simulation across their whole organization. This pathway is based on 4 key elements: training, which builds internal expertise; application support, which reduces risk in the initial projects; ready-to-use models, which accelerate practical adoption; and finally, the integration into company workflows, which is the real long-term objective. When these elements work together, simulation can much more easily become a concrete part of everyday engineering and decision-making activities. The first element is training. However, this is not about generic courses, but about programs built around the company's real products. The goal is not simply to learn how to use a software tool, but to enable people to immediately work with virtual models that are aligned with their daily engineering activities. For this reason, training can cover both the use of open modeling and simulation tool, as well as more application-focused topics related in general to fluid power and hydraulic systems modeling. Every SmartFluidPower license includes an initial training program of approximately 12 hours, tailored to the company's level of expertise and objectives. In many cases, training is built directly around examples and applications close to the company's own products, so that simulation is immediately connected to the real engineering problems. The key idea is simple. Simulation becomes truly valuable only when the people using it can integrate into their everyday technical decisions. A common mistake is to think that the simulation adoption must be immediately extended across the entire company or to all products at once. In practice, the most effective approach is often the opposite. Start from a pilot project on a concrete application. So select a specific product or a component or system. Build the virtual model with the appropriate level of detail. Validate the model using experimental data or other simulation, for example, CFD, and analyze the results focusing on a real technical objective, such as performance mapping, stability issues, or efficiency. This approach offers three main advantages. First, it allows you to generate immediate value on a real use case without having to change the entire company process from the start. Second, it enables the company to build internal expertise while working on something useful and directly connected to its activities. From this initial case, it then becomes possible to progressively scale the approach to other products and systems within the company. In addition, the pilot project helps identify the appropriate level of detail and integration of simulation that is really needed within the company's specific technical context. One of the most important aspects is transforming models into a company asset. If each simulation remains an isolated case, its value stays limited. But when custom libraries are developed, several advantages are present. Virtual components validated in past projects can be reused to model other company products. Knowledge becomes standardized, meaning that scattered, implicit, or individual expertise is transformed into structured, reusable, and consistent models. Over time, these libraries evolve from simple collections of components into true repositories of company know-how. So design choices, parameterizations, validated behaviors, and accumulated product knowledge are progressively embedded within the models themselves. This leads to shorter development times and, above all, avoid starting from scratch every time. In practice, simulation stops being just a design activity and becomes a core knowledge infrastructure within the company. Another critical aspect in the adoption of simulation concerns who actually uses it within the company. In many cases, simulation remains confined to a small group of specialists who handle both model development and results analysis. This can create a technical bottleneck, limiting the spread of simulation within decision-making processes. For this reason, one key objective is to separate modeling complexity from the operational use of models. Simplified interfaces make it possible to use complex models without interacting with their internal structure, keeping all the underlying physics within the simulation engine. As a result, simulation can be used not only by specialists, but also by engineers involved in design, testing, and technical decision-making. Post-processing is also more guided, allowing users to obtain relevant performance indicators without having to interpret raw data each time. Finally, the availability of multiple licenses within the packages enables simulation to be extended across the entire engineering team, supporting widespread adoption. The goal is not just to simplify the use of the tool, but to make models and simulation results truly accessible and usable by different roles within the company, even without advanced modeling expertise. One aspect that is often underestimated when introducing a simulation environment is its ability to integrate with the tools that are already used within the company. The goal is not to replace existing software or disrupt established workflows, but rather to create a more connected and efficient ecosystem. From this perspective, the open source nature of OpenModelica is a key advantage, as it provides high flexibility both for integration with external tools and for customizing company workflows. OpenModelica, for example, can interface with CAD system, automation and scripting environments, control software, and post-processing applications. This makes it possible to manage data and generate custom reports, perform data analysis and parametric optimization, and connect models to tools already used internally. The platform can also be integrated into automated calculation and validation processes, for example, to run simulation batches, virtual testing, or automatic result generation. Another highly relevant aspect is support for open model exchange standards such as FMI and FMU, which allow dynamic models to be shared across different platforms. In particular, there are three main scenarios that can arise when sharing models. The first case is that customer uses the same environment, that is OpenModelica plus SmartFluidPower library. Models can be exchanged directly with the option to fully or partially hide internal information. Second case, the customer uses a different lumped parameter software. The model can be exported and shared as an FMU, that is a protected black box with dimensionless exchange ports. The third case is that the customer does not use dynamic simulation software. In this case, OpenModelica still allows the model to be provided in a form usable with open source tools. This means that regardless of the context, there is always a way to make the model usable. This is particularly valuable both in collaboration with customers and partners, and in multi-domain environments with different tools. So this interoperability makes OpenModelica not just a modeling environment, but a highly versatile platform on which to build custom tools and processes. This example shows how simulation can be integrated across different areas of the company processes. For example, within the VIS Hydraulics Innovation Center. In the R&D phase, the dynamic model is developed in parallel with the real component. This makes it possible to anticipate many design decisions before building the physical prototype, and to reduce the number of development iterations. During the testing and validation phase, simulation is correlated with experimental data to improve model reliability and accelerate analysis and troubleshooting activities. Simulation is also used to evaluate the component behavior in real application or specific operating condition, supporting technical discussion with the customer. Finally, more simplified models enable quick preliminary checks and support technical decision-making even in the early stage of evaluation. This case highlights an important point. The value of simulation grows when it is no longer confined to a single activity, but becomes an integral part of the company's daily workflow. An important aspect when introducing simulation is avoiding approaching that are too rigid or overly complex from the very beginning. For this reason, the adoption path is typically built progressively, based on the company's needs and level of maturity. In many cases, the first step is a pilot project, focused on a specific product or application. This makes it possible to evaluate the value of simulation in a concrete way, working immediately on a real case, reducing initial risk, and building internal expertise. Of course, this approach is not always necessary. In companies that already have experience with simulation or internal expertise, the process can start directly with the operational use of the platform, of the software, and development of application specific models. The next step is a more structured use of the platform, including dedicated training, development of custom libraries, and the progressive integration of simulation into company workflows. When simulation becomes a stable part of internal process, integration can be further extended through custom interfaces, dedicated workflows, and also simplified tools that have the aim to enable wider adoption, even among non-specialist users. The key idea is that there is no single adoption level that fits all organizations. The path can grow progressively alongside the company's technical and organizational needs, and the ultimate goal is to achieve full autonomy in simulation usage and the effective integration into everyday decision-making processes. Alongside the adoption path we have discussed, the platform is available in different configurations, designed to match the company's required level of use and integration. At the software level, there are two main packages. The first is the basic package, which includes modeling and simulations of systems. The second is the components package, which extends the model with more detailed libraries dedicated to hydraulic components. These configurations are complemented by the continuous development of specialized library, which progressively expand the platform's capabilities for specific application cases. One example is the library dedicated to estimating the pressure losses in complex hydraulic paths, such as manifolds, which will be available soon and will further enhance the modeling of real systems. These packages can be used in two ways. The first is purchase with maintenance, while the second is an annual subscription license, allowing for more flexible use over time. In both cases, the platform includes up to 10 licenses to extend usage across the engineering team, along with the annual technical support and an initial training program of approximately 12 hours. The idea is not to lock companies into a rigid configuration, but to build a scalable solutions that evolves according to the level of simulation adoption. At this stage, the goal is no longer to explain simulation, but to understand whether and how it can be useful in a real context. Every company has different processes, products, and level of maturity. For this reason, there is no single standard adoption path. The most effective way to assess the real value of simulation is to start from a concrete case, a product, a system, or a specific problem. On this basis, we can build an initial technical assessment ranging from a simple feasibility analysis to a full pilot project. The objective is not to sell a tool, but to understand whether simulation can become part of your decision-making process and how to integrate it without introducing unnecessary complexity. If it makes sense, the first step in general is a short technical discussion with our team aimed at identifying a real case to work on together. From there, a progressive path can be built without rigid constraints and with a level of adoption that is aligned with your company's actual needs. Okay, thank you for
Thank
your
you
attention.
for attending this webinar and for being part of our series. Over the next few days, you will receive the presentation slides and the full webinar recording and a dedicated in-depth article covering today's topic. If you have any questions, feel free to reach out. We'll be happy to support you, whether it's about simulation, specific application, or how SmartFluidPower solution can fit into your workflow, we're here to help. We also invite you to complete the short end of webinar questionnaire that you can see in the chat or in the slides, because your feedback is extremely valuable to us as it helps us continuously improve our content and better understand your needs. By completing the survey, you will get also access to the SmartFluidPower trial library and a free dedicated technical consultation on your specific use cases.